Hello, we're going to be talking about solving linear equations today. Linear equations in one variable. Later in the semester we'll talk about linear equations with two variables. Now, the techniques we're going to talk about in this section are techniques you're familiar with. You've seen them before in Algebra 1. And it will all come back to you if you don't remember right now. They'll all come back to you when you look at a few examples. But the first question I want to ask you is, what's a linear equation? So when you look at this equation that's right here, we know that this is a linear equation. Why? Well, here I see ax plus b equal to c. In this case, a, b, and c, those letters all represent numbers. X in this case is the variable. Usually you know who's a variable and who's a number from the context of the problem, and in this particular problem I know that x is the variable. Okay, now this variable is linear because we don't see an exponent here. When an exponent doesn't appear, the default is the exponent is 1. That's the accepted standard. So the exponent on x is 1, and if that's the case, this is linear in x. So here's one of the properties we're going to use to solve linear equations. This property is called the addition property, and what it says is if you have an equality, you can add a constant to both sides of the equality and maintain the equal sign. Similarly, you can subtract a quantity from both sides and still maintain the equal sign. These properties are like the previous. The multiplication and division properties both state that if you have an equality, you can multiply both sides of the equality or divide both sides of the equality and maintain the equal signs. There is a caveat though. The divisor in this case, the divisor can't be 0 because division by 0 is not defined, not in this math class, not in any math class you'll ever take. Okay, so we can start by solving this simple linear equation. And so the objective is to solve for the variable. The variable here is x. So to solve for x, what we're going to do is isolate x. Isolate x means x should be all by itself on one side of the equal sign. So to achieve that here, we're going to subtract 12 from both sides. And when you subtract 12 from both sides, you see x is 28. Now we could check that to verify that that's the case. Since 12 plus 28 is 40, we know that x equal to 28 is in fact a solution to this equation. Now we have a few other simple examples. In each case there's a letter which represents the variable. Now in the first case, the variable is p and it has a coefficient of -3/5. Now, when we solve the equation, we want the coefficient of the variable to be just 1. We want to know what 1p is equal to, not what 3/5 p is equal to or -3/5 p. So to get the coefficient to be 1 here, what we would do is multiply by the reciprocal. So if we were multiplied by the reciprocal of the fraction, 5 over 5 is 1, 3 over 3 is 1, -1 times -1 is also 1, so the coefficient of p here will be 1. So now we know what p is equal to, and if we simplify the fraction on the other side, we find that the variable here is -4/9. For part b, this is pretty simple. This one, w is the variable, it's divided by 2.2, so if we just multiply by 2.2 on both sides of the equation, then we find w is 8.8. And here, the coefficient is -1, so if you multiply by -1, you find that x is -6. So each of these equations has a unique solution, meaning there's just one solution in each of these equations. So now I would like you to just pause and solve this problem on your own, and we'll check the solution in just a moment. So please pause and solve this. Okay, so I'm assuming you solved this, so we'll go through it pretty quickly. The thing to do on the right hand side is use distributive, so hopefully you did that. If you use distributive on the right hand on the right-hand side, 5 times z is 5z, 5 times negative 2 is negative 10, and then the process is the same. You want to isolate the variable. One way to do that is to subtract 5z from both sides, and if you do that on the right-hand side, you make the z go away. 5z minus 5z is 0, so you just have negative 10 on the right-hand side. And to continue isolating the variable, we'll subtract 2 from both sides. So now we have 6z by itself, divide by 6, and you find z is negative 2. You can check the answer to confirm that negative 2 is indeed the solution to the problem. Again, please pause the video and solve this equation, and I'll go through it very quickly, and you can see if you got the right answer. Okay, so hopefully again you distributed the negative 3 into the parentheses, and after you do that you can collect some like terms on the right side and on the left side. After you collect the like terms, again you want to isolate the variable. One way to do that, one approach, is to subtract x from, or add x rather, add x to both sides. When you've done that, we'll want to subtract 14 from both sides, and then divide by this coefficient of negative 2. So if you got x equal to 4, good job, that's the solution. Now this one's a little more complicated. It has nested parentheses, so there's parentheses inside the square bracket. So in order to handle this one, the best thing to do in this case would be to work from the innermost parentheses and then out. So the inner parenthesis is here, so I'm going to first distribute the negative 3 inside the parentheses. So if you do that, you end up with negative 3y plus 15 inside the square bracket. Now, since y minus 3y, these are both like terms, you can combine them and get negative 2y. And of course, by the way, we did use the distributive property on the right-hand side as well. So you should be able, without too much difficulty, to be at this step. Now once you're at this step, the next thing to do would be to take care of the negative 4 outside the parenthesis, outside the square bracket here. You need to use distributive again. So negative 4 times negative 2y is 8y, multiply by negative 4 and 15 and get negative 60. So now you're in a position where you can isolate the variable. So to isolate the variable, one way to do that is to add 10y to both sides. So you end up here. And then, of course, we're going to want to add 60 to both sides to isolate the variable. And we end up with this equation. The last step here would be to divide by the coefficient. The coefficient here is 18. So if you divide by 18, you find y is 4. So the solution here is y equals 4. Now this one is a little different because there's some fractions. But the technique with fractions, if you use this particular technique I'm going to mention, it will help you out if you're not so fond of working with fractions. So what we're going to do here is multiply both sides by the LCD. So the denominators are 4, 3, and 2. So the LCD is the least common multiple of those numbers. So, you know, what would be the LCD in this case if you had to add the fractions? Well, so you should think about that for not for too long. We need a number that's a multiple of 4, multiple of 3, and a multiple of 2. Well, 4 and 3 are called relatively prime. They have no common factors, so their product is going to be the least common multiple of those two. So, and that's 12. And since 2 divides 12, 12 will be the LCD. So we're going to multiply both sides by 12 to get rid of the fractions. On the right-hand side, though, you can see first, this is optional. You don't have to do this step first, but you can multiply by the 1/2 to get rid of the parentheses there. But then, when we multiply by 12 on both sides, we'll be able to get rid of the fractions. Of course, we'll have to use the distributive property. So 12 will multiply each term in the parentheses on the left-hand side, and likewise 12 will multiply 2 terms on the right-hand side as well. Once you've done that, because the LCD is a multiple of all the denominators, you'll be able to reduce these fractions. So 12 times a fourth is 3, 12 times a third is 4, 12 times negative 1 is negative 12, 12 times a half is 6, 12 times negative 2 is 24. So that's why we have these coefficients. Now we can collect like terms. So this becomes 7w, and now we can isolate the variable. If we subtract 6w from both sides, we're here. Add 12 to both sides, we're here. So the solution in this case is w is negative 12. Here's another one with fractions. And why don't you try to solve this one? So pause, please pause the video and try to solve the problem. Okay, so like before, we want to multiply both sides by the LCD. The LCD, again, is the smallest multiple of all the denominators. And in this case, you can tell by inspection that number is 10. 10 is a multiple of 5, a multiple of 2, and a multiple of itself. So if you multiply both sides by 10, you will need to use the distributive property on both sides. So on the left-hand side, 10 times this first expression is here, 10 times the second expression is here, and on the right-hand side, 10 times 2 over 1, that's here, and then 10 times this expression is here. And since 10 is a multiple of all the denominators, we'll be able to reduce the fractions. So that cancellation is shown. 10 over 5 is 2, 10 over 2 is 5. This is just going to be 20 because no reduction is possible. Then here 10 over 10 is a 1. So we have this new equation, but now the multiplier, the factors here, are all whole numbers rather than fractions. So now we'll proceed in the usual way. We'll have to use the distributive property twice on the left-hand side, and on the right-hand side we won't really need to because this is a 1 and 1's the identity under multiplication, doesn't change anything in the parentheses. So if we use the distributive on the left-hand side, we have 2x minus 4 and then minus 5x plus 20. Now we'll collect the like terms. So these are like terms, negative 4 and 20 like terms. So collect the like terms, and then we're going to isolate the variable. To isolate the variable, we can subtract x from both sides, and now we'll subtract 16 from both sides, and then divide by the coefficient. So the unique solution here is x equal to negative 2. This one is, well, it's like fractions, only it's decimals. So to clear the decimals here, we want to multiply by a power of 10 so that these are whole numbers rather than decimals or equivalently fractions. So this number, 0.55, this is 5/10 and 5/100. So this is 55 hundredths. So if you move the decimal point over 2 places, this will be a whole number. This only needs 1 decimal place, but this one also needs 2 decimal places. So to move a decimal point 2 decimal places, we need to multiply by a number with 2 zeros. That number would be 100. So if we multiply both sides of the equation by 100 and use the distributive property, 100 times 0.55 is 55 because it moves the decimal point over 2 places. And here, if you move the decimal point over 2 places, you get 60. And move the decimal point over 2 places here, you get 205. So now we have the simple linear equation. Again, like before, we want to isolate the variable. To isolate the variable, we can subtract 55 from both sides, 55x, and then divide by the coefficient of x, which is 150. So the solution here is negative 60 over 150. And, oh, that was a little bit quick, sorry about that. And I think that can be reduced further. Let me go back there. Hold on a second. Yeah, that can be reduced further because this is divisible. Well, it's certainly both divisible by 10, so that would be negative 6 over 15. And those are both divisible by 3, so that would be negative 2/5. Sorry about that. Okay, so everything all the equations we've looked at so far are called conditional equations. Conditional equations are equations that have particular solutions. They're true for some values of the variable, but false for other values of the variable. So they have solutions conditionally. The solution is conditional upon the value of the variable. Other types of equations are contradictions and identities. Contradictions are equations for which there are no solutions, and identities are equations for which all numbers are solutions. So here's 3 different equations, and I won't go through the details of these. I'd like you to do them on your own. I'd like you to pause and solve each of these and see what you come up with. Okay, so assuming you've solved these, if you go through this equation, you'll end up at the, depending on how you solved it, you'll have one number equal to another number, and those numbers won't be the same. For example, you may end up with 2 is equal to -3. So if you have a case like that when you're solving, that's a case of a contradiction, which is what you should have gotten from solving A. Now if you solve B, this equation is an identity. So if you solve this equation, you'll end up with a number equal to itself. For example, you may end up with 3 equal to 3, in which case that's always true. Doesn't depend on the value of the variable, so this equation is called an identity. This last equation is a conditional equation. There's only one value for which this equation is true. And that particular value is x equal to 5, because 20 minus 3 is 17. So this is called a conditional equation. Okay, so that's the end of 1.1. There is an assignment on Connect Math at Connect Math for section 1.1. The other section that we need to do today is section 1.2, and in section 1.2 there are some word problems. So we have this here. I wanted to remind you about different keywords for arithmetic operations. So the arithmetic operations that are here, of course, are addition, subtraction, multiplication, and division. And here's some English language phrases that are appropriate for these operations. So if you use the language A is increased by B, that would the appropriate mathematics for that language would be A plus B. Or a total of A and B means A added to B. You can take a look at all of these. I think you should read every one of them and believe or understand or commit to memory these phrases for each of these different operations, because it does they do come up, these phrases, when we look at word problems. Now here's one thing I just wanted to point out with subtraction. The difference of A and B would be in math, in arithmetic, A minus B. A minus B, of course, you know what that is. B subtracted from A, you would still write that as A minus B. A decreased by B would still be written as A minus B. B less than A is still written as A minus B. Even though B comes first in the phrase and A comes second in the phrase, A is first in the subtraction, B is second. So order does matter with subtraction. It doesn't matter with addition or multiplication, but order does matter with subtraction. And also it matters with division. So you might, please do take a look at these. Okay, so we'll take a look at this first example. The sum of two numbers is 39. Okay, so two unknown numbers, you add them together, you get 39. One number is 3 less than twice the other. What are the numbers? So to start this problem, we'll let x represent one number. If x is one number, this phrase, or this sentence rather, needs to be translated to represent the other number. So how would you translate this phrase? One number is 3 less than twice the other number. We need 3 less than twice x. So to write 3 less than twice x, here's twice x, and here's 3 less than twice x. So this represents the other number. Now what do we know about these numbers? We know the sum is 39. So what we need to do is add the numbers up and get 39. The first number is x. The second number is 2x minus 3. So this equation represents this description, that scenario. So then we have a simple linear equation. Solve it in the usual way. X plus 2x is 3x. And again, isolate the variables. So we'll add 3 to both sides, divide by the coefficient, and we find x is 14. So x is 14. What's the other number? The other number is 2x minus 3. So that means we need to take 2 times 14 minus 3. 28 minus 3 is 25. So the two numbers that are appropriate in this example are 14 and 25. Okay, so here's a consecutive integer problem. And in this case, we have the sum of two consecutive odd integers is 516. We have to find the integers. Okay, so we don't know what numbers these are, so we have to start somewhere. So we'll start with x is the first odd integer. Now, if x represents the first odd integer, what's the next odd integer? Well, if x represents an odd number, say x is 3, the next odd integer would be 5. So how do you get to 5 from 3? You have to add 2. You have to skip over the even integer after the odd one. So x plus 2 would represent the next odd integer. Now what we know about these integers is 3 times this sum is 516. So we need 3 times this sum. So 3 times the sum of the first and second has to be 516. So the equation would be 3 times the sum of the first integer and the second integer. So here's the linear equation we need to solve. And to solve this, there are nested parentheses. And like before, we want to work from the inside out. This inner parenthesis does not have a multiplier. So this inner parenthesis doesn't serve a purpose. So we can just remove it and add the like terms. X plus x is 2x. And now we need to use distributive on the left. So if we do that, we end up here. Again, we'll isolate the variable, subtract 6 from both sides, divide by the coefficient. The first integer is 85. So if the first integer is 85, the second integer must be 87. Okay, so now we have a new problem to look at. Here we have a percent application. So in this application, a woman invests $5,000 in an account that earns 5 1/4 simple interest. The money's invested for 3 years. How much money's in the account at the end of the 3-year period? Okay, so for this problem, you do need a little background information. You need to know or remember how interest works. So the way interest works is the interest that one earns on an account is the principal. Principal is the amount that you invested times the rate times time. This is the basic equation about how interest works. Interest is the amount you invested times how long it's been in the account, which is the time, and the rate, what's the percentage interest you're getting. Principal times rate times time. That's the interest. So we need to, we can use that here. If X is the amount of money that's in the account, well, and we know what that is actually. This is the total money in the account. She invests $5,000, right? So $5,000 is the principal. The principal is $5,000. The rate is 5 1/4%. The time is going to be the 3-year period. So that information is here. Principal is 5,000. The rate, 5 1/4%. Well, 5 1/4, a quarter is 0.25. So this number is 5.25%. You need to convert the percent into a decimal. So 5.25%, if you divide by 100, you move the decimal point over 2 places to the left, and here's the rate, 0.0525. Time is 3 years, so t is equal to 3, because in this equation, time represents the time in years. So now we have everything all together. We can figure out what the interest is. The total money that's in the account is what she started with plus her interest. Okay, so her principal is $5,000. Then the interest on the account is principal times rate times time. So it's a pretty simple calculation. We want to add to 5,000 the amount of interest that she earned, and so the interest earned in this setting would be $787 and 50 cents. So here's the total amount of money in the account after 3 years. Okay, in this problem, a college bookstore uses a markup of 40% on all books purchased wholesale from a publisher. The bookstore sells a calculus book for $179.20. What was the original wholesale cost? Okay, so in this problem, or in this question, we know the selling price for the book. The question's what was the original cost? Okay, so that's an unknown. We don't know what it is. So we'll let X be the original cost. So the selling price for the book is going to be the original cost plus markup. And we know what the markup is. The markup was 40% of the cost of the book. So the markup is what the original price was times, the 40%, which is going to be times 0.4. So if we just make the substitution, the selling price, which we know here is $179.20, that's equal to the original price, which was unknown, plus the markup. The markup is the original price times 0.4. So now we have, again, a simple linear equation in x. X plus 0.4x, we can call that 1.4x, right? Because this is 1 and this is 0.4x. These are like terms, so you can add them. So now to solve for x, we just need to divide by the coefficient. And if you divide by the coefficient, you see x is 128. So the original cost of the book to the bookstore, that cost was $128. Okay, so that's it for section 1.2. Again, there's assignments for both of these sections in Connect Math, and that's what you need to do before we meet again in class. So you have your work cut out for you. Please get busy and make it happen. Okay, thanks so much, and I